Hello everyone, welcome to our video on Matplotlib, an essential Python library for creating stunning visualizations. In this session, we will explore how to turn raw data into insightful charts and graphs, perfect for presentations, analysis, and storytelling. Whether you are a beginner or preparing for your information practices as per CBSE syllabus, this video is your gateway to mastering data visualization with Matplotlib. We have tried to cover all aspects from exam perspective. So post this video, if you follow our hands-on session on Matplotlib, you would have covered your entire Matplot-related syllabus from exam perspective. Let's get started. The image that you are seeing, several of these might be new for you. We will spend few minutes looking at some of the important aspects of it. What you are seeing on this screen is important component of a Matplotlib diagram. The one above the diagram with anatomy of a figure, that's your title is. So you can set whatever title you will set through set title or title attribute. It will be shown at this place in your figure. Then on y-axis you may see label. So this is the field y label. This is the field that will be shown as an annotation on what is there in your figure on y level. Similar thing you can see on x-axis with name x level. On each of these axes, you can see where x-axis is, where y-axis is, and then you can see tick. So this is your unit of data set at that level of granularity it is shown. So you will get opportunity to set your tick both on y as well as x level, and if you want, typically we set one tick, but you can also set major and minor ticks. Some of the other component, if you see on, if you can follow my mouse, so where legend is, this is the place where if you are having several plot or even individual plot, it will have some color coded thing with certain description, which will talk about what kind of data set it has plotted or it is talking about. Then if you can see markers of various set, so we will actually see in our tutorial Matplotlib supports variety of markers, and we'll see ways of using it. Then one figure or one plot can have several subplots. So if you see this particular larger figure is divided into 4 by 4 subplots. So you can have 16 different figures where actually you can plot individual aspect. So with this, where we talked about title, your X level, your Y level, we talked about legends, ticks, and then we talked about how you can actually set level across both x-axis as well as y-axis. There are a lot more things, but we'll keep it simple from first level course on this topic. And as we build upon it, we'll get several opportunity to come back and look in detail at some of the other components of Matplotlib. Now we are going to use in our Python Matplotlib library, and this is having a module called pyplot. So for all practical purpose, we'll be actually importing pyplot from Matplotlib, and that will be our uh, you know a module where actually we have collection of functions to work on these plots, right? As we just discussed, this will be first calling a function plot, which will create a figure, which will be the overall window for outputs, as we saw in previous slide. And inside this figure, you'll be having plotting area, region, axis level, ticks, titles, etc., etc. Now each of these functions modifies the figures, creating a plotting area, plotting lines, or adding labels or titles or whatever. Best practices always include a chart title and label the axis, provide a legend for multiple data series. A very simple example, if you want to plot x versus y, assuming they are actually series, you can simply use plt.plot in a bracket x comma y, and then you can use plt.show to display the created figure. We will take an example and a very bare minimum set of PLT related functions that you need. So we have just printed 3 date and temperature on those dates. As you might see on the screen, we are having pyplot we are first importing matplotlib.pyplot as PLT, and then we are actually having our data set as a list in date and temperature variable. And to plot it, we simply call plt.plot with date and temperature. As you can see on right hand side, on x-axis you have 2512, 2612, 2712, and since it is a simple line by default, you see from temperature from 8.5 going up to 10 and then coming back to 6.8. If you want to save it, and this is important from your exam perspective, from your information practices paper, plt.savefigure and then path to a png file with the path to a file with png extension will work well. Now we look at some of the pyplot functions to print various charts. So plot, as you see, and its syntax, star arcs, where actually you are having a scale x, a scale y, and data. So by default, if you want to scale down x and y, that you can provide here. Otherwise, simply you actually provide your data across x and y, and to plot x versus y at lines or markers, you simply call this. If you want to draw a bar plot, which is rectangular one, you have to call bar, and then by default you'll be having some height, width, and then alignment related data point. The bare minimum you can simply give the array or series, and this will actually plot them. Box plot, which is an important type of chart, where just by looking at it you can get the median, you can get the 25th quantile, 75th quantiles, and outliers. That can be done through box plot. Again, several other specific one, but by default you can simply call box plot or the data point, and other details are sort of optional. For an histogram, by it will automatically determine bins range and density as well as weights on its own. If you want to provide it, that's actually taken. Otherwise, there are default calculation, and by default you can simply call your histogram on that series. It will go. Pie, pretty similar. You have actually idea for explode, where inside a pie chart, part of that pie will actually come out, right? And then you have things for auto percent, where by default you can actually it will print in percentage term, and then you can actually kind of use you know uh, how many digit, right? So 0.2f or whatever, and then you have colors and some other aspect. A scattered one, so a scattered plot across x and y, where you can actually try a C marker, C map, and other things. We'll see some of these details going forward. So in this slide, we're actually just talking about various charts that we can print using plot. Now, in Matplotlib, we are also talking about markers. So on your screen, we have included some commonly used one, where you can use a symbol like dot and it will be dot. You can use a comma, it will be comma. A small, O will be a circle, V will be a triangle down, and then your the other one is triangle up. Then you have left and right using left, left less than and greater than signal. And if you want to print a square, pentagon, as well as plus, so there you have SPP, and then you have a bunch of these things. We'll see some of these markers, and it will take time for you to kind of really make regular use of it to get comfortable. But you can actually keep in mind at least some of the star and others, which are just like the same symbol, but it will be actually enlarged in your Matplotlib. Then there are actually variety of color pattern, RGB for sure, which are for red, blue, and green. So whenever you are giving colors, you can actually give RGB or list of these depending on how many different column of data that you are using. And then from there on, you have symbol for white, black, yellow, and magenta, plus several others. Then Hmm. एक मिनट. So we were talking about our various chart types. Now, to call it, simply plt.plot, plt.scatter for a scatter plot, plt.plot for basic plot or basic line plot, for bar, plt.bar, and they can provide categories and values. For histogram, plt dot, hist, and then your data. For pie chart, plt.pie, where you can give your levels as categories. Now, to print a simple, basic line plot, the first thing, as you might see here on your screen, import matplotlib.pyplot as plt, and say for example we are having several values of x and y as a list. You can simply call plt.plot xy, and then you can add title, x label, y label, with appropriate strings, and simply call plt.show. So we'll be seeing several of these hands-on several times. You might have seen actually plenty of it with actually our data, basically pandas related, and data frame related discussion as well. Customization, so you can change colors. For example, you can use colors equal to red or blue or whatever. You can add markers, where you have to specify markers, and then you saw the symbol, right? O for big O, then a star. We saw actually several triangle and other pattern. Adjust line, where you can actually say the line style. So you can have dotted or whatever it is. Then you can actually set grid lines with plt.grid. So there will be actually grid lines around your data. And to add legend, you can actually call simply plt.legend, right? So we have simply, let's take another example. In the same last example, if you add color as green, marker as O, right? So if you see all the changes in data point, there are markers, right? And line style as dotted line, right? And then you can actually you have changed the title little bit, x level, y level is same, and then we are calling plt.grid as true. So you see there is actually rectangular grid printed for actually easier reference to where your data set is, and then you have added legend and and that's it. Visualization using Pandas. So Pandas also support, its own ability to sort of, draw all these plots. And say, for example, what you are going to do, there are two variations. You can call df.plot, and then you can specify the kind of plot that you want. So line, bar, histogram, box, all of that is supported. Or you can call df.plot, and then I can call the line, bar, histogram, box. Either of these, both syntax. If you see types of plot, and if you are able to follow my mouse, either of these are allowed, right? How we are going to do, simply call df.plot. If you see on the right hand side, kind is bar, title is bar plot from pandas, and then plt so. So what it is showing, title, it's already, if you see legend A and B, we don't have to set the legend here explicitly, right? So pandas had determined, because it is having more organized information about the data, which column and all, and by default it is showing column as legends, and that's why actually you start seeing them differentiating benefit from it. We'll see several examples around pandas plotting variations. So in this case, we are starting with, we have say data about, weekly sales, right? We have just taken some random, sales data point, 7 data point between 5,000 and 9,000 for week 1, week 2, and week 3. And then we have actually set up, our data frame for with sales figure for week 1, week 2, and week 3. So you can imagine some number for week 1 being anything between 5,000 and 9,000, same for week 2 and same for week 3, right? Then how you can call df.plot, and then what we have to specify, kind is equal to line, because you want to say line graph, right? Then you can give color. Since we are having 3, you have assigned a list of RGB. So our week 1, week 2, week 3 will be plotted in RGB, and then you have set up the title as meta weekly sales. On X level, you have set X dot level as days, Y dot level as sales in rupees, and then we are simply calling PLT dot so, right? So df dot plot, that kind of plot that you want. You can specify all other things there, even color, title, X level, Y level. You can even do with PLT dot, actually, again that. Now we have done some customization. If you see on the bottom right side, and what we have done in this particular case, you see the the second call to df dot plot, right? So kind is line, but marker is same. Sorry, color is same, but we are trying a marker as star. So at each of these, change in data direction, because of line graph, you will see those markers, and what we are using here is stars. So you can see those stars there. We have also set a marker size. You can set some numeric number. We have used 10, and line style we are having dotted, line width we have set 3. So you can play around. You can load the data, and then on the df plot with various line speed, various line style, various marker size, color pattern. You can play and try and beautify your plots. Let us look at box plot. Box plot is very important because in many of your data analysis related work, right? You can understand lot of things if you do a very simple box plot of your data, right? Now the one where we are actually calling this box plot is on set of students and their marks across 5 subjects: English, math, Hindi, science, and social studies. And marks could be anything between 10 to 100, and then you can assume name of a students or whatever as another column. Now if you just look at the box plot on the left hand side, you should actually make yourself comfortable. There might be some question asked, and you might be interpreting box plot in your daily life almost on a daily basis, right? So here, if you see on the bottommost with small circles, these are the outliers, right? So on the bottommost part, or you'll see outliers. Then you get the minimum, right? Minimum, for example, in this particular case, minimum could be 30, right? Then you get quartile 1, the 25th percentile, right? Then you get lower quartile, quartile 2, and then you get middle quartile or median. So the middle line that you are seeing, right, in each of these box, that is the median. And then you are having 75th percent quantile, and then quartile 4, and then again imagine maximum and outlier on the upper hand side. I have not shown them because of a space issue. So on box plot, if you see and if you look and analyze, right, I mean actually to call this, what you have to do, say your data is in a CSV, so you loaded CSV, you take your data frame, right, and then you simply call plot kind is equal to box. Then we are having title, color, X level, Y level, and then you can set a bunch of other things, right? So you see the diagram is blue. Let us look at in Hindi, right? There are outliers around 90. It means that only very few students have got marks around 90. In actually, if you look at science, there are very few students who have got marks less than 50. So there are outliers around 40, right? Hindi ranges anywhere between actually say 30 to 80. Your social studies goes from 50 to almost like 98, right? So you should actually start interpreting box plot, and this will be actually used in your day-to-day life on a very, very frequent basis. Histogram, right? So histogram are those stacked bar charts, and what we have done here is we have taken for government website, we have taken minimum and maximum temperature, and for actually month-wise annual minimum and maximum temperature for several hundred years. And we are just considering the annual mean and annual max for each year. We have actually so you can call, we are just calling on the left hand side, if you see pd.read csv. and then we are specifying the columns used, which is annual mean and annual max. There are other columns in the data set as well. Then to call actually your histogram, you can simply call df.plot kind is equal to histogram, and then you can say what your y is. Your y is annual mean, if you are just using the annual mean data. And what we have done on top of that is we have done some customization. So we are getting the midpoint, and how we are getting the midpoint, we have actually called, we have taken and array all the data set as an in an array, and then we are actually calling np.histogram, so that we can get the bins and ages information in variable y and ages. Then what we have done, we have actually looked at the ages array and calculated its midpoint, that is the mid. And then what we are doing is, on the top of df plot, we are actually creating another plot which is with your mid and y, and then we are actually giving it a shape which is of this particular kind. Then we have just title, x level, and so you should actually practice more around this, but without these actually the customization that you are seeing, you would have simply called df.plot, and it should have given what kind it is. Now, how you can draw a pie chart? So this is across a state. There are geographical areas and forest cover, and for each of these northern eastern states, say we want to actually kind of look at pie chart, right? So that you can get the idea that which state is having what percentage of it. And to call pie chart, so what we have done first is we have got this data in a data frame, right? And there we are having a state, geographical area, and forest cover. And from there on, we are considering your state and forest cover, and on that plot we are actually saying kind is equal to pi. Then on y hand side we have y level that we have set here is forest cover. Title we have set is forest cover of northeastern states, as you can see. Region we have set as false, so that we don't see many of those unnecessarily. Explode, so explode is what that you are seeing some of these pies coming out and looking a little bit attractive, and we have given 8 weight. If you see in this exponential, right, first one is 0.1, and second, third, fourth, fifth one is 0.2. So that's why you see 2 of these coming out literally other than others, right? And yeah, that's it. So that's your actually pie chart. Summary: Matplotlib is a kind of versatile library for Python plotting. Customization enhances the relatability of plot. Pandas provides integrated visualization for data frames, and you should be actually practicing more and more around this. So with this, we come towards the end of our Matplotlib. Hope you you benefited a bit. Just as a summary, what all we talked about is we introduced what are the different components of a Matplotlib diagram, where we talked about title, x level, y level, ticks, legends, grids, and several other components. Then we introduced the APIs for variety of common charts. So around bar, histogram, pie, scatter plot, box plot, several of those. Then we talked about different color pattern, markers, line style, setting of width, some other customization, and then we took series of examples where we tried plotting single line customization, then histogram customization, then pie chart customization, and then we took several actually data frame related things. Now we might set up one more discussion for your exam related question, particularly for information practices folks, and otherwise we'll be having plenty of these while discussing your data frame. So see you guys in our data frame video, which we are actually going to just which is going to be series of videos, at least 2 on that topic again. So hope to see you there. Do like and subscribe my channel, and comment with any specific queries that you might have. Thank you.